In this lesson I will go through what the normal is and how to use the dot product to create things like light and shadows. That means that we are going a bit deeper into vector math, but we are still on a basic level. So, what is a normal? I think the easiest way is to change this plane into cube. So just select the plane, press delete, and then Shift A, go to mesh and select your cube. So now we have our beloved default cube in. Then go to material properties and create a new material. And we don't need a principle, so take that away. And now we should use the texture coordinate. So Shift A, input, texture coordinate. And we are going to use the normal. So take the normal and just drag it out to the surface input of the material output. Then go to render view and check what we have. So we have 3 colored sides and 3 black sides. So a normal is always depending on that you look on that. And what it is that it measures how the face is towards a certain axis. So if this face at the top here is exactly just pointing at the z-axis, you get the value of 1 here, meaning that we now get blue in the z-axis. And if a face is pointing towards a y-axis, you get green, as we get here, or white in the y-axis, and the same for the x-axis. So if we now rotate this cube just a little bit, so I just press R and do some random rotation like this, and pressing Ctrl A and apply the rotation, you can see that the colors are now changing a bit, because now we get some degree from the other axis together with this face as well. And if I now change this cube into Suzanne the monkey, I think it will be even clearer. So I press delete now, and then I press Shift A, go to mesh, and we use the monkey. And we can subdivide it a few times. So I go to modifiers, add modifier, subdivision surface, and we can just use 1. It's enough for now. And we go to our material properties and we select the material that we did right before this. And now you can clearly see that every face that has the same direction has the same color, and if it changes just a little bit, then we also get different colors on this monkey here. So if it's really towards the x-axis, you get a lot of red, and the same for the y-axis and for the z-axis, so we have blue up here. So that is how our normal works. So it measures the different variations from the different axes. A very simple example of that is when you would like to do snow or dust, and you only want that on the top here, because then you can use the normal and say that I don't want anything that isn't a z-axis. I just want a z-axis, because that will give me that place that I would like to put all the dust and the snow. And we can do that just by separate things here. So we drag out from the normal and we write separate, and we find separate x, y, z. So if I now take the z-axis into the surface here, you can see now that we get it almost like a light at the top, and it's very, very dark at the bottom. So that means that we now can color only the top if we want to. So I can put in a color mix here just to show you. So Shift A, color, and there you have the mix RGB. So if it's 1, then we color it, and if it's not 1, it's 0, then we don't color it. So let's say that we have some green at the top here. Then we change this into green, and we put the Z-axis into the factor and put that up here. We can change the top to black so you can see it. And then you see that everything that is pointing towards the Z-axis will then get green here. And the same if we do like a tree and we only want the moss from the north, or let's say X-axis here, then you just change this to use the X-axis instead, and you get everything from this direction. So that is normal. And by normal you can then find all the directions that your object has, which means that you can find things like different types of angles, where the edges are, and do stuff like I did now, where you paint only a portion that is towards Z-axis or X-axis or whatever. So that works really nice. And now I'm going to introduce you into something called a dot product. There is of course a formula behind dot product where you multiply and add every axis together, but you will not in that formula see how you use that in practice. But in practice what you get if you have 2 vector inputs and both of these vectors have the same length, then you get the point that is perfectly between those 2 vectors, which means that it's almost like a flashlight where you get that exactly point between. And I can show you how that works very easily. So what we do now is that I take and press Shift A and go to Converter and Vector Math. And in that vector math I have a dot product. So you can select the dot product and you can take the normal in the top here and just let rest be for now. And then you can see that, okay, we have a vector in that is vector A, and then we have the second vector or vector B, and the combination of those 2 will get a scalar value out here. So we only get a single value. We don't get like a vectors. We don't get the x and y and z position. We get only the length out between these 2. So if I now put this into surface here, you can see that this is completely black. So what do we have this for? Okay, we can try to put something in here. So we take this UV and put that in. And now you can see that something is happening. We get white on this side and we get black on this side. And that is because UV go from 0 to 1. So when those 2 meet each other, then we have 1. And where they are like in the opposite direction, then we have 0 here. But this is not so practical. We don't get any good information from this. So let's do something else that is much more fun and where you really see how it works. We start by adding another object, an empty. So go down to your object mode, press Shift A, and there you can just go down to empty and plane axis. And just drag that out in x-axis, so just press G, X, and drag it out like this. Then go back to the monkey and change the UV to object instead, like this. And in object, you select empty. That means that we get the information from the object here instead of using the monkey, even if we have a material in the monkey. So we get all the data, all the information, like location and everything that is in that object, that we get out from here. So when we now move this around like this, you can see that it works almost like an inversed flashlight. So just press a G and you can move it like I do. So by using this, we can pretend that this is the sun here. So how to do that? Well, it's just to inverse it. So I can just press Shift A and convert the math, put that in and multiply with -1 like this, and then we have it on the other direction. So when I now go around, it works exactly as a flashlight. So this is good, and this is exactly how it works, but I don't know if you remember it, but I said that the dot product measures the distance if both these are exactly the same length. So this, if I now drag it away a lot like this, then you get a much sharper white here. And if I take it a bit closer like that, you get a little softer or not so much of this white here. And we don't want that. We want to go from like 0 to 1. We know that the backside should always be 0, the front should always be 1. And to get that working together with the dot product, then we need to introduce something new that is called normalize. So as soon as you get information in to a vector, you can then get, if you have like 2 vectors and you measure distance from them and so on, then of course the length can be very different. So you can have some dot that are like 100 meters away, and in some occasion that doesn't make any good math, because then it's hard to work in the range of 0 to 1, which is always the easiest way to measure things when it comes to material and 3D. So in that case we use something called normalize, and we can put that between object here and the dot product. So Shift A and then go to converter, vector math, and we here have normalize in the right top list here. So you select that one, and as soon as you select that, depending of course where you have your empty, you could see that it turned down the white a bit. So now it's more soft, because now it will never go over 1. It doesn't matter where you put this, it will always be 0 on the back and 1 here, because now we have the same length, because normally always go from 0 to 1, and object now, the location here, it transforms to whatever it is into a range of 0 to 1, since we use this normalize. So that is how these things works, and you can of course then put in like a mix RGB or whatever to make that happen here. And you can do the same thing with shadow as you can with light. So what we can do right now is that I can add a plane, for instance. So I can press Shift A here, mesh and plane, and we can have some size on that plane. So we can press S for scale, and let's say 10 like this, and don't forget to apply the scales. So Control A and then scale. So now we have something that is 20 meters here. And we take up the monkey a bit, so just GZ, just so we have some distance here. And now you can see we have a shadow on the side because I have a light here. We turn that light off like this, so we don't have any light at all. And now I would like to have a shadow here. We can see if we take away, we put a new material here, and we take away the principled, like that. Oh, sorry, we take only away the principle like that. Now we can put in just an input of RGB just so we see something. So Shift A, input RGB, and we can put that to the surface, and now we have it like this. And now you can see there is no shadow or reflection or anything, just this static reddish thing like that. So now I will take away the material for the monkey here and create a new material for this red here. That the monkey is red now is because we are working directly from the RGB to the material output surface, and what it's really doing is that it changes into a light. So the red here is the light that is now lit onto the monkey from this plane here. So the monkey doesn't have any material. Okay, back to the plane. Now I would like to have shadow on this plane, and that we can use this monkey for. So if I now take away the RGB here and I use the texture coordinate again, so Shift A, input a texture coordinate, I use my normal and a dot product, so Shift A, converter, vector math, and in your vector math you select the dot product. See if we can find it again. You have it down here, and we will now use our monkey in our plane. So we select the monkey, and now we use the object, and as you remember from the monkey here, we should now normalize the position from the monkey. So we press Shift A, convert to vector math, and then we select the normalize. So now we have the normalize in, and we have the object in, and we can put that into our vector here, and we can use the normal from our plane, put that in here, and we get a value out from this to the information here. But I don't know if you remember it, but if it was facing directly towards what we was looking at, it was 0. So we needed to reverse it. So we do that as well. Put in a multiply, Shift A, converter, and a math. And we can put a multiply here. And we can put -1 here. And now we have the information from this monkey. So if I now move that around, you can see that we get light from this. Okay, so that is really good, because then we can use that for light, but we can also of course use it for shadow, and we can do that by just using a mix RGB here. So Shift A, converter, color, and mix RGB like this, put that into factor, and if you now just drag down the lower one here, you will then get a shadow under this monkey. So when you go around, you have a shadow under Susan. But if we now would like the sun to be a little bit on the right or the left for Susan here, then we just move this in the plane here, because we get an information that is normalized between 0 and 1 into here, but we can of course add information before this object or the normalize here. So if I just put in a new vector math here, pressing Shift D to copy, and I add like this, then I get information that I can move here. So if I now move the first one, I can then say that, okay, my sun should be around here, or perhaps a little bit back. So now we are pretending that the sun is behind here. And if we are now moving Susan around, it will always be like we always have the sun slightly behind Susan here. So that is very easy to then create these shadows by just putting in information and change a little bit the location of where Susan is with just using this add here. By that you can then of course put in like a fake shadow in whatever you want to do. So that is how it works when you will add a shadow into something. So now we have learned 3 things. We have learned about what the normal is. It's how the face is leaning towards different axes. We have learned how we can use a dot product to get exactly the length between 2 different directions. So you get the final direction out as a scalar value. And we have learned about normalize, which take any value from a vector and transform it into a 0 and 1 range. So that is all for this lesson, and I'm sure we will use it in more future lessons. But hopefully you understand this and just practice until the next lesson. So I say bye for now.